It's for me a pleasure to introduce you Estrella Fernández de Sevilla. Estrella is a degree in biochemistry and master in physiology and neuroscience by the University of Seville. During the time in Seville, she also has spent some time doing short research stays in Łódź in Poland and also in Sheffield, the UK. Then she started her PhD in the Ignacio Torres laboratory at the Cajal Institute, studying the role of IGF-1 through orexin neurons related to stress and some other research lines. In the last few months, she has done a PhD stay at the Magendie Institute in Bordeaux, and she will present some work today that has been recently published in Molecular Psychiatry. The title of her talk today is Insulin-like growth factor 1, mitigate post-traumatic stress by inhibiting AMP-Kinase in orexin neurons. So Estrella, thank you very much for your willingness to share with us your work. And you can please proceed, just share your screen and go ahead with your presentation. Thank you.
Okay, you see the screen?
Yeah, okay, yeah, everything's fine.
Hello everyone, thank you for the introduction and also for inviting that now he is in the Chucarroar Center, and also directed by Dr. Jaime Pignatell, that is in Cajal Institute. So first of all, I want to introduce that learned fear on fear memory is an adaptive behavioral response that allows us and to other animals to predict potential threats based on memory of past adverse experience. But sometimes when there's an excessive fear, there's some stress-related disorder that we can develop, as it is post-traumatic stress disorder. And these post-traumatic stress disorders, they have been published that could be related with a higher risk of dementia. First, our main objective is to study IGF-1, and we have seen that IGF-1 could be related with the Alzheimer's disease, as we saw that IGF-1 could stimulate the clearance of the beta. And also the authors have been seeing that the levels of IGF-1 are diminished with dementia. And the other main character of this history that I want to tell you today is the orexin. And also there's some relationship between orexin and Alzheimer's disease, as it is the dysregulation of orexinergic system. Maybe it could be related with the sleep disorders that AD patients have a lot. And so with this, I'm gonna start with the insulin growth factor 1 or IGF-1, because several years ago in our lab we saw that it's related with vulnerability to stress in mouse and in humans, and also has been related all of these years with depression, using as antidepressant, and recently, important for this work, also with the fear and the extinction of the fear. So we know that insulin growth factor 1 is in the whole brain and also in other parts of the body, but searching for a target related with anxiety, we focus on the lateral hypothalamus, concretely in a discrete neural population that is called orexin nucleus or hypocretin nucleus, because they receive their name because of the neuropeptide they synthesize, that is the orexin or the hypocretin. There are two isoforms of orexin, orexin A and orexin B, and these neuropeptides bind their G-coupled receptor, that they are orexin 1 receptor and orexin 2 receptor, and these two receptors are markedly distributed in the brain, having different function, as it is feeding, autonomic responses and arousal, reward addiction, fear memory, anxiety, and stress. But here we are interested in the orexin implication in fear memory. As I told you before, there's some relationship with dementia, but with the orexin, mainly all the works are related with the fear, the anxiety, and the stress, and also some of them with related with the depressive symptoms. And the most new thing is also that could be a target for PTSD. So first of all, what we checked was if these neurons, the orexin neurons, presented the IGF-1 receptor, and we saw that yes. And for that, we developed a transgenic mouse based on the Krylov-Spee model, in which orexin neurons they don't have a functional IGF-1 receptor because they don't have the exon 3. In this transgenic mouse, we call fear of mouse. So as we saw in the work I said before, that the IGF-1 could be related with the vulnerability to stress, we did this experiment that consists in putting osmotic mini pumps in the brain of a mouse. We use a control in fear of mouse, the transgenic with IGF-1 receptor in the orexin neurons. And then we expose this mouse to a rat, that is a predator test, the rat exposure test. That is a physiological way to produce fear in mice. And then 2 days later, we measure the anxiety in the elevated plus mice, measuring the time they spend in the open arms as the time less stress. I mean, the more time they are spending in the open arms, the less stress are they. What we observed in this test was that the animals, only the control mice with the entrance of IGF-1 presented an amelioration of the symptoms of anxiety because they spend more time in the open arms. This same effect we didn't observe it in the fear of mouse. Also, we measure other behavioral tasks that they are in the rat exposure test as they are decreasing, that is the absence of movement inside the box, and also the grid contact, that is the time they spend close to the grid, close to the rat. And again, the only group that presented amelioration of these fear responses was the control mouse with the IGF-1 entrance. So, as we wanted to know if there's an effect in the PTSD, the thing we did in this work I presented is doing a PTSD model based on the fear response that is mainly known that is implicated in this disease and also in the way to study in mice. In this case, we use a fear Q conditioning, but in this case, we use an intensity of the shock higher, 2.5 milliamperes, to develop that PTSD. So it consists in a battery of different experiments. First, a few tests to measure the freezing from the day before. And then we wanted to see the context-dependent fear response that is a trait observed in PTSD that consists in put the mouse in the same context that they received the trauma, the first day with the shocks. And we did 7 days later and 35 days later. And to measure another kind of trait, the PTSD trait, we wanted to see the anedonia that is related with the depression symptom in PTSD patients. And for that, we use the sucrose preference test that consists to choose water sucrose that is more paraterral, and in normal condition, a mouse is gonna drink more sucrose. So what we obtain of this model, compare the normal intensity of the shock and the higher, was a higher freezing in the Q test, the 7 days later in the context recall, the 35 days later recall also more freezing, and here you can see the less intake of sucrose that mean they have more depressive symptom of anedonia. So we love all this. We hypothesize that orexin circuits may participate in stress-related behaviors modulated by IGF-1. And to start what happened with this fear of mouse without the IGF-1 receptor in orexin neurons, we studied the Q conditioning that briefly consists in 2 days. One of these conditioning that is apply non-aversive stimulus associate with an aversive stimulus, a sound, with a shock. And then the next day, in a different context, the mouse is gonna remember that the sound produced the day before the shock. So they're gonna do the freezing, the absence of movement. And we measured that freezing in the Q test, and what we obtained was that the feedback mouse presented an aberrant higher freezing. And to know what happened in the orexin neurons, in this case, we sacrificed the mice 90 minutes later, and we measured by immunostaining by CFOS the activation of the orexin neurons. You can see here that in the feedback mouse, the percentage of orexin neurons activated were higher. Also, another nucleus of interest for us is the locus coeruleus, that is implicating in the field circuitry downstream of the orexin neurons, and also is participating directly with the freezing. And as you can see here, the percentage of the deoxynitroglycerase, in this case, because it's the locus coeruleus, was higher. So next, seeing that the orexin neurons maybe they were more activated, we wanted to know if we inhibit the orexin neurons. For that, we use chemogenetically inhibition with the DREAD inhibitory, and using orexin mouse control and FIROC, we injected the virus bilaterally in the lateral hypothalamus. And then we submitted this mouse to field conditioning as we did before. And what we obtained related to the freezing was that the feedback mice treated with the DREAD, with inhibition, because in this day you apply the CNO that is responsible for the inhibition of the cells with the DREAD. We observed that the freezing was recovered, was lower than in the feedback mice injected with a control virus, that in this case was AMP-Kinase. We saw that this amelioration that it was previously published for other authors, it was also recovered in a control mouse. So taking advantage of this tool of the DREAD, we wanted to know what happened further. As I explained before, the context recall 7 days later, but in this case, the intensity of the shock was the normal, was at 0.3, not the intensity as the PTSD explained before. And in this case, the feedback mice presented with the control virus presented a higher levels of the freezing that also was recovered with the DREAD. So the effect was also here important. And then after more time, 35 days later, again the same tendency was observed. The feedback mouse with the control virus presenting a higher percentage of the freezing, that also it was not observed in the feedback treated with the DREAD. And to know what happened with the anhedonia, with the sucrose preference test, the only group of animals that the percentage was lower of the intake of the sucrose was the feedback and cherry. So with all of this, maybe we could say that suggests that there is an overactivation of these orexin neurons that could be involved in PTSD-like behavior. And to know why this could happen, we wonder if in some way the excitability of the orexin neurons were different in these animals. So we performed triple immunostaining to the orexin neurons with VGLUT2 and VGAT, and we measured the excitatory and inhibitory ratio. And what we observed in basal conditions was that the feedback mice presented a lower EA ratio, giving us idea that maybe they are like more inhibitory in basal condition. But what happened in feed conditioning? This mouse, after the feed conditioning, after the Q test, we did the same immunostaining as the same time as the CFOS, and in this case, the EA ratio was the opposite. In the feedback mice, they presented an EA ratio higher. That we could say with this that maybe the fear reverses the E ratio on orexin use in fetal mice. To confirm if IGF-1 is doing some effect in orexin neurons, we administer IGF-1 intraperitoneally to control mice, and we sacrifice them 2 hours later. And what we wanted to see was if this architecture of the synaptic architecture of the orexin neuron was changing. For that, we did immunostaining against the activity marker of the GABA receptor and GLU receptor. And corresponding with the GABA-B receptor, the phospho-GABA-B receptor, we saw that the mice treated with IGF-1 presented less phospho-GABA spots inside the neurons. I'm not sure if you see the image, but we measured the spot inside the neurons, and there was lower in this case in the mice treated with IGF-1. And also we measured the phospho-GLUR, as you can see here in the panel. And in this case, only we saw the difference between the percentage of orexin neuron that they presented the phospho-GLUR. It was higher in the case of the mice treated with IGF-1. And further this, that is published that the active form of the GABA-B receptor is depending of AMP-K, the phospho-AMP-K. So we did the same. With this group of animals, we performed immunostaining, but in this case against phospho-AMP-K. And what we saw was that the levels of phospho-AMP-K spots was lower in the case of control mice. That correlated perfectly with the levels lower again with the phospho-GABA-B. So with all of these results, we wanted to know what happened in vivo, mainly in an PTSD model. So first, I remember you that this PTSD model is based on the fear response with a higher intensity of the shock. We performed the fear conditioning, and 6 hours later, we injected the mice with IGF-1. And what we observed was, here in the color blue, you can see that the freezing time was lower in this group of animals, relating with the control. Also in the context recall 7 days later, you can see here, and 35 days later. And also the anedonia was recovered. As you can see here, the percentage was higher. So next, what we used was the compound C, that is an inhibitor of the AMP-K, to see if what we saw before with the immunostaining of the levels lowers of the AMP-K will happen with this drug. And what we saw here in color pink, you can see the bar, that it was the same tendency, a lower freezing time in the Q-test, even lower in the context recall 7 days later, you can see here, and also 35 days later. And the other PTSD trait, also the anedonia was recovered in this group of animals. And finally, to see if it's dependent, this IGF-1 AMP-K in this protocol, in the PTSD model, what we did, it was inject the IGF-1, again, IP 6 hours later, but in this case, 30 minutes after injecting IGF-1, we injected ICAR. ICAR is a drug that is an activator of AMP-K, and what we observed was that the beneficial effect of IGF-1, of the decreasing freezing, was abolished in this case. As you can see here, there were no differences in the Q-test in 7 days later in the context recall, 35 days later, and also there's still anedonia in this group of animals. So yeah, maybe there's this correlation between IGF-1 and the effect of inhibitor of AMP-K. And what we postulate is this model that in a control mouse, in control conditions, IGF-1 is binding his receptor, in some way is inhibited the phosphorylation of the active form of the AMP-K, and for that the GABA-B receptor is decreasing. And what happened in a fetal condition where the IGF-1 receptor is non-functional? IGF-1 is not inhibiting the active form of AMP-K, so the GABA-B receptor is increasing. And it's similar to what we observed in the EA ratio in basal conditions that were like more inhibited these neurons. And to test also this correlation between IGF-1 and PK, we did this experiment in vivo that was in normal field conditioning with normal intensity of the shock, not the PDSMD model. We injected the IGF-1 after the field conditioning, and we didn't observe any effects. We expected that because the orexin neurons they don't have a correct IGF-1 receptor. But when we injected the compound C, the inhibitor of MPK, we saw that there was a decreasing in the freezing time, as you can see here. So this was a recovery of the phenotype in this case. And just briefly, to comment that the experiment in the field of mouse in this mouse model was also done with the virus in the same context of the freezing. Just to finish, the take-home message of this work can be like one, the absence of functional IGF-1 receptor in orexin neurons imbalances glutamatergic and GABAergic inputs. Second, that early inhibition of excess orexinergic activity in feed of mice or IGF-1 or the compound C, that is the AMP-K inhibitor administration, in control mice submitted to intense peer learning correct these PTSD-like traits that I mentioned. And the third, that as PTSD is a risk to develop dementia, I explained in the beginning, and also that the IGF-1 signaling is diminishing in elderhood, and that the orexin activity could be unbalanced, we suggest that this early modulation of the axis, IGF-1 orexin, could provide a novel target for ameliorating disease such as Alzheimer's disease, and also maybe the use of this inhibitor of MPK. So thank you so much for your attention, and all the collaborators in the lab.
All right, thank you very much, Estrella. A nice presentation.
I don't see.
Can you hear me?
Yes.
Okay. So the paper is now open for discussion. As I said earlier, if anyone is interested in making questions, please just raise your hand or send me a message through the chat stating your name and your affiliation, and I will give you the opportunity to pose the question directly to Estrella. So while we wait for any questions, let me just remind everyone that the CIBERNED Webinar Series are held every other week on Thursdays at 3:30 p.m. You can check the program for the upcoming webinars in our webpage, cibernet.es. I think the program is ready till the end of July, and in the next couple of days, it will be the program for the rest of the year. It will be posted there. So please go there and check all the seminars till the end of the year. Okay, so any questions?
Okay, so Miguel.
Yeah, Rafa, please.
I have a question. Okay, all right. So Estrella, very nice work. Okay, congratulations. I have just some general questions regarding. So you have been basically modifying your model, the hypothalamus, isn't it? Yes. So you have been injecting hypothalamus, but all the fear conditioning, all the fear learning, you know, just probably you can correct me if I'm wrong. But the place where this learning is taking place is in the amygdala, in the lateral amygdala. So what is then the relationship between then the orexin neurons in the hypothalamus and the amygdala, lateral amygdala?
Yeah, well, we didn't see differences in the learning. In the learning, we didn't see differences.
I see.
So only is the reason I only show the Q test. Not in the conditioning, there were no differences. So the learning is okay in this mouse model, and also in the circuitry that you mentioned, the orexin neurons are innervating the locus coeruleus, yeah, and the locus coeruleus is innervating the amygdala. But yes, there's a circuitry. For me, it's not all the time in the same direction, because there is so implicated the hippocampus.
Because then I wanted you just to elaborate on how will be in a physiological situation to develop the post-traumatic stress disorder in the hypothalamus. So those neurons will be somehow a sensor for some sort of, let's say, cue that is triggered by post-traumatic stress. So how would you then include in a physiological context? Then yeah. So which are the readout, the signals that are generated in the post-traumatic effect? So these neurons are going to be important to, to detect this signal, or how it's going to be?
Well, for example, are implicated in the metabolism, and also with the age. With the age, are starting to have unbalanced problems to the signal. So they are degenerating with the age.
I see. And then I have two more questions. So orexins are well known because of they regulate, they regulate the feeding behavior. It's important for feeding behavior, and also it's important for the sleep. You know that the orexin neurons are normally destroyed in some sort of narcolepsy, and the typical behavior of orexin knockout mice is narcolepsy. This is very impressive, So I'm wondering, do the mice, your mice lacking the IGF receptor in the orexin neurons suffer from eating disorders or sleep disorders?
Yes, they sleep more. Yes, it was the previous sleep more time.
They sleep more. Okay.
Yeah. It was the previous paper when we characterized the mouse model.
I see.
Yeah,
okay.
They have differences in that.
Okay. Very interesting. All right. Okay. Thank you. And then regarding the feeding, do they have any feeding disorder or not?
They don't eat more. Well, the pigs, I'm not sure right now, but they have the circadian problem with the metabolism.
Okay.
Yeah.
Okay.
I mean, for me, is they don't balance the big changes when they don't have the IGF-1 receptor.
Okay, and also really it was to me that you when you talk about the imbalance between the excitatory and inhibitory circuits. So basically, so you saw that in terms of synaptic markers. So then you say that you are then remodeling the circuits. So there is a remodelation of the circuits. So there is a remodelation of the synapses because. So this is very impressive. That is, you are inducing structural changes. So what do you think about that?
I think because it is needed that the orexin neurons are activated after the fear, because it's an adaptive behavior and you have to freeze it. But sometimes if this is exaggerating and it is not down, that excitatory signal is over-excitated, they are not regulated by itself or the surroundings. I don't know if I explained good.
No, it's really, to me, just to induce such a change in the synaptic components structural level. That's a big effect, So and so it will be interesting to know what's behind that, and then follow this thing up. Okay, very good. Anyway, very interesting. Okay, so thank you, Estrella.
All right. Thanks, Rafa and Estrella. Any other questions or any other comment? So please just either raise your hand or send me a message through the chat. I don't see any incoming messages or any raised hands. So let's wait for maybe 30 seconds, 1 minute, if any latecomer want to make any questions. No more questions? Okay, so if there are no more questions, then it's time to close the session. Not before thanking once again to Estrella for his nice presentation and his willingness to share her work with us. Thank you everyone for attending, and just goodbye. So have a great afternoon. Bye.
Thank you.